Alright, so I'm just going to go ahead and make recordings. Not everybody is up to 10 through 13, so I'm going to make recordings to put online for them. And let's start with number 10. Graphing linear function word problems. So these problems are just like the one that we talked about earlier, in that you need to know two quantities, two parameters. You need to know where the line starts, and you need to know how it's changing. And that we're going to be constructing that linear equation. Here's where the start goes, and here is where the change goes. But this time I need to identify the start and the change from a word problem. So again, it's y equals blank times x plus blank. This is where the starting point goes. And this is where the thing that tells you how fast it changes goes. In other words, the slope. In other words, the rise over the run. So I'm constructing a linear equation again, but I need to identify this thing and this thing from the word problem. So let's read it. It says, Zane is a dangerous fellow. It's kind of a rhyme. Zane is a dangerous fellow, and he likes rock climbing on volcanoes. That is dangerous. One time when he was 20 meters below the edge of the volcano, he heard some rumbling, so he decided to climb out of there as quickly as he could. He managed to climb up 4 meters each second to get out of the volcano safely. So there's two numbers there that look like they might be important. And those two numbers are 20 meters below and 4 meters each second. Now in the equation mx plus b, there's only room for two parameters. So those two numbers are going to go somewhere in the equation for the parameters. I just need to know which one is which. And let's see. Okay, so for the starts, for the intercept, B, here's some of the things I'm looking for. I'm looking for where it starts. That's also known as the initial cost or the beginning, or something that has to do with x being 0. So I'm looking for those kinds of things to find the intercepts, the starting. And then for the slope, I'm looking for, it's pretty simple, I'm looking for the words each, every, or per, because those are all things that are going to tell me a rate, or a speed, or a change, or a ratio. So all those things belong to slopes. So, okay, so I've got Zane, and he's on a volcano. He started 20 meters below. 20 below, and I need to make sure that I put a negative with that because of the below. So that's negative 20 is where he starts. Starts on the volcano. And then for slope, it's really simple. I'm just looking for the word each, every, or per. And this one says 4 meters each second, so that would be 4 meters each second, 4 meters per second. Notice that this m stands for meters. I don't want to confuse you. This is going to be telling me the slope. And I know that because of the word each, because it's a ratio. So 4 is the rate. So he starts down here at negative 20, and then he's going up 4 as he goes up the volcano. Okay, so let me erase some of this stuff at least. And first I can construct the equation y equals blank times x plus blank. The intercept we decided was negative 20 because he starts off 20 meters below. And then the slope was 4 because that's the rate at which he climbs the mountain. And then we talked about what the graph would look like. It would start down here at negative 20, and it would increase by 4 meters every second as he climbed up the mountain. So let's go ahead and answer the question. All right, this one, I don't see an equation. It says graph the equation, graph the thing. So I'm going to have to know the equation in order to get this right. I move the first dot where it starts, which was down here, 20 meters below, and then every 1 second, so if it goes over 1 second, he's going to climb 4 meters. So let's see, 20, 18, that's 2 meters, and then 2 more meters to 16. You're going to be tempted to put it here, but notice that that's at half a second. You wanted to go over 1 full second. So if I were to draw this triangle, it would be up 4 meters and over sideways 1 second. Up 4 meters, sideways 1 second. Up 4 meters, sideways 1 second. All right, so that's the graph of that line. And just like always, I'm going to go a little bit faster on this one. A battery with 20% of its capacity is connected to a charger. Every minute that passes, an additional 5% is charged. So this is where it starts, and then every minute, that's the slope. Okay, so I'm going to start with 20% full, and then every minute it goes up. Every minute it goes up 5%. So if I go sideways 1 minute, I should go up 5%. And then sideways 1, up 5, sideways 1, up 5. All right. Notice that this is sideways 1, because I'm going sideways, this is 1, and up 5 to 25, 30, 35, 40, so 25 is right here. There's the word per. That must be the slope. So the slope is 12. And after 30 minutes of driving, that's actually going to be the x-intercept. Boy, that's a tricky question. So I want to get to sea level after 30 minutes of driving. So sea level is at 0. So he's starting down here under the ocean, and he's rising up until he gets to sea level. And that happens after 30 minutes, so this is where he comes out of the ocean. Where does he start? I don't know where he starts. I know the slope. So the slope is 12. So every 5 minutes, I need to multiply, because this sideways is 5, so I'm going to have to times 5 times 12. So 5 meters per minute. How much for 5 minutes? Okay, so each one of these minutes is going to go up 5. Let me double check. Each one of these minutes, 12, sorry. So it's 5 times 12. So each minute is 12. So how much for 5 of those minutes? So each minute is 12. So that's 12, 12, 12, 12, 12. So there's 5 of those 12 meters per minute. All right, so that's 5 times 12. And that's 60 meters that he's traveling. Okay. So after 5 minutes, he goes up 60. Okay, so up 60, sideways 5. So everything's looking good there. Well, it looks like maybe I need to actually start it there, down there.